The principle in physiology that I think really explains it was proposed a few decades ago. It's called the Randle effect or the Randle cycle, although there's no cycle involved. That refers to the fact that free fatty acids block the use of glucose by cells. And that was demonstrated frequently in hospitals when they were giving nutrition support to people who couldn't eat or cancer patients who were losing weight very fast in the form of a soy oil emulsion. They saw that about 15 minutes after injecting this nutritional dose of emulsified soy oil intravenously, that people would get hyperglycemic. And the Randle effect is sort of an instantaneous thing, but when the fatty acids that are involved in blocking the use of sugar, when those are polyunsaturated, they produce long-range damage that keeps the Randle effect going, keeps blocking the use of sugar. A group, I think it was in South Carolina, the lead author of one of the papers was M.X. Fu, who showed that the glycated proteins that are seen in diabetic people, that glycated hemoglobin, for example, and they blame that on glucose or fructose fragments sticking to hemoglobin and other proteins. But Fu and his group demonstrated that polyunsaturated fatty acids are much more powerful glycators, sticking fragments, 3 carbon, 5 carbon, and longer fragments from the spontaneously oxidized polyunsaturated fats stick to the proteins. And so the free fatty acids not only block the sugar use instantaneously, but they produce these advanced glycation end products, the AGEs, that are associated with diabetes and aging. So the chronic effect of a high-fat diet, if the fat diet is predominantly unsaturated, produces not only diabetes but all of the things that result from glycated proteins.